Assalamualaikum, my name is LIEZDA BATRISYIA binti ZALI from CDCS1434A.
Hi and Assalamualaikum, my name is NURUL alias SAFEYYAH binti AMINUDIN. I am from D1CDCS1434A. My matrix number is 2022878538.
Assalamualaikum and hi, my name is FARAH WAHIDA binti JUSOH alias YUSOF. I am from CDCS1434A. My matrix number is 2022857014.
Since the mass between two persons are different, we must put them on a different distance to create an equilibrium, as example shown. Academics once said, "Give me a stick long enough and a pivot, and I shall move the world." Let's move on to another example.
My weight 37.5 kilograms. My body weight is pushing the seesaw around anti-clockwise.
My weight is 50 kg. My body weight is pushing the seesaw around the clockwise.
Anti-clockwise moment. The lighter person exerts a force of 375 newtons 2 meters from the pivot. So my moment is 750 Newton meters.
Clockwise moment, the heavier person exerts a force of 500 Newton, 1.5 meter from the pivot. So his moment is 750 Newton meters.
Moment force. Moment is defined as the product of the force F and perpendicular distance D from the line of the action of the force from the fixed axis. The turning effect of the force is called moment. For example, a spanner turning around a fixed nut. A moment can be calculated using this equation. Equation of moment force. Moment equals to F multiple T. If the force is measured in newtons and the distance in meters m, the unit for moment is in SI system in Newton meter. Since moment is a vector, it has both magnitude and direction, where the direction of the moment is usually defined as a clockwise or anti-clockwise. What is a difference between anti-clockwise moment and clockwise moment? For anti-clockwise moment, if a force acting on a body has the tendency to rotate the body in an anti-clockwise direction, then the moment so produced. For clockwise moment, if a force acting on a body has the tendency to rotate the body in a clockwise direction, then the moment produced.
We will move on to question 1. Two objects with masses of 3 kg and 2 kg are placed on a beam at distance of 7 meter and 4 meter respectively, as shown in the figure above. Find weight F to keep the system in equilibrium. The answer for question 1, we can answer with two ways, which is one is total moment equal to 0. Second is total moment clockwise equal to total moment anti-clockwise. First, we're going to solve the total moment equal to 0. Since the given questions is in kg, we need to convert it in Newton, which is we're going to multiply the kg, which is 3 and 2, with 9.81. And then we're going to times with the distance, and we're going to equal to 0. Then you will put the F into in front, equal to 56.898 Newton, as you can see. And then we're going to solve the second one, which we use total moment clockwise equal to total moment anti-clockwise. We need to know which one is clockwise and which one is anti-clockwise. Clockwise is in this way, and anti-clockwise is in this way. So we list the clockwise and anti-clockwise equal to each other, and then we're gonna put F as the mean, and we're gonna get the same answer as before, which is 56.898 0.898 Newton. That's it. Thank you.
Next, question 2. Beam is in horizontal equilibrium with multiple forces acting on it. The beam is 6 meters long and is supported at its midpoint, which 3 meters from either end. 3 forces act on the beam. 1. A 20 Newton force downward at the left end. 2. A 30 Newton force downward 2 meters from the left end. And 3. A 40 Newton force downward 1 meter from the right end. Determine the sum of the moments of the forces about the midpoint of the beam. So, to determine the sum of the moment of the forces about the midpoint of the beam, we will use the principle of moments. The formula that we use to solve this question is moment equals to force times distance. So, first of all, given that length of the beam is 6 meters and also midpoint of the beam 3 meters from the either end. So in this case, I took 3 meters from the left end. So now we need to find the distance of these forces from the midpoint of the beam. So first of all, distance of the 20 Newton force from the midpoint is equals to 3 meters. And second, the distance of the 30 Newton force from the midpoint is equals to 1 meter. Since 20 Newton is 3 meters, so we need to minus 2 out of the 3. So we will get 1 meter. Then, distance of the 40 Newton force from the midpoint is 2 meters, as the question stated that 40 Newton force downward 1 meter from the right end. So we will get 2 meters. Next, we calculate the moments about the midpoint. So first, moment due to the 20 Newton force. So 20 Newton force, 20 Newton times 3 meters. So we will get 60 Newtons. Second, moment due to the 30 Newton force is 30 Newton times 1 meter. So we will get 30 Newtons. And the last, moment due to the 40 Newton force. We will take 40 Newtons times 2 meters and we will get 80 Newtons. Now, we sum up the moments. So total moments equals to 60 Newton plus 30 Newtons plus 80 Newtons. And we will get the last answer, 170 Newtons.
For conclusion, the result of a force and its effort arm is referred to as a moment of force. There are further examples of the moment of force at work in our everyday life. That's all from us. Thank you.